thousand frightening fantasies, the doubting disease, melancholy, scrupulosity. All of these phrases describe obsessive compulsive disorder, or OCD, a psychiatric disorder that causes the sufferer to experience constant, frightening, unwanted thoughts called obsessions that can only be relieved by performing a physical or mental ritual called a compulsion. Although there are many different kinds of OCD, ranging from fear of germs to fear of hellfire, with modern neuroscience, we're beginning to understand the root causes behind one of the most misunderstood mental disorders of all time. After reviewing brain scans of OCD patients and healthy patients, researchers realized that in OCD patients, the orbital frontal cortex was in overdrive. This led to the theory that the neural connection between the orbital frontal cortex, the caudate nucleus, and the thalamus was damaged. In a healthy brain, when the cortex, our center of rational thought, notices something upsetting, it sends a message to the thalamus, our center of primal emotions like fear and pleasure, which in turn sends a fear signal back to the cortex. The caudate nucleus mediates this interaction and works to stop the thalamus from going into overdrive. So, when this is broken, the thalamus can't stop sending the cortex fear signals, which is why those frightening thoughts can't leave the sufferer's mind. The thoughts then snowball into worse and worse anxiety. As if broken neural connections weren't bad enough, hormones play a role too. A suspected factor of OCD is an imbalance of a brain hormone called serotonin. When neurons signal each other, they send chemicals called neurotransmitters between them through a space called the synaptic cleft to pass messages along. Serotonin is a neurotransmitter that makes you feel calm, so the brain interprets a lack of it as feelings of anxiety. This then triggers the brain to release fear hormones like adrenaline and norepinephrine, which spread to the body via the sympathetic nervous system to produce the fight or flight response. This signals the body to respond with things like a fast heart rate and shaking. What's more, these hormonal feelings preside even after the initial electrical trigger in the brain is long past, thus adding to the snowball effect of OCD. Even though there's so much we know about OCD, there's still so much that we don't know. Why is serotonin so low? Why is the caudate nucleus damaged? We don't know, which is why it's so important to study neuroscience. Considering that OCD affects about 3% of the general population, and that people who suffer with OCD are 10 times more likely to commit suicide than those without, studying neuroscience is a great way to not only save minds, but also lives.